Live. Oh, Lana, no, you're not meant to share the um StreamYard link. They're joining through YouTube. You get it.
Hi guys, please if you are in please if you can see me, can you please say something in the chat box?
All right. Hey, everyone. Good afternoon. Welcome to this engineering design session. This is the first of many sessions we'll be having in this internship. Are you guys ready? If you can see this, if you're watching, please drop a comment in the comment section. I can see people are joining us. If you're joining us, welcome. Please drop a comment in the comment section. Good afternoon, everyone.
Hi guys, so I'll moving straight to business that we have today. If you go through the documents I sent, if you go to the document I sent, basically, let me introduce myself first. My name is Oluwala Najai, and this engineering design processes for ECX mentorship program. So basically, I sent a PDF today, sorry, a document to the group chat just before this meeting started to briefly explain what engineering design is all about. Well, we'll be doing a lot in this course, but then I'll need everybody to be on board so that we could make so that we can make the most out of it. Basically, engineering design is is the method that engineers use to identify and solve problems. It has been described and mapped out in many ways, but it has five common steps basically. Anyhow you want to define engineering design, that's five common steps, which is first of all to define the problem, second of all to gather information, third to generate multiple solutions. The solutions don't have to work. Just basically not generate, just think about multiple solutions that can be applied to solve that problem. Then you analyze each solution and you select one, the one that meets the requirements, the one that is fast enough, easy enough to understand. Then you test and implement the solution. After you do that, you go back again to evaluate the test and the implementation of the solution.
Hello, are you still with us, Lana? Hey, you're back.
Okay, sorry guys, I had to switch from my phone. to from my PC system to my phone so that we can it can go on unhindered. Um,
You're welcome back.
I don't know. Can you all see me?
Yeah, we can see you.
Okay, thank you. You can see me now. That's good. So I'll just go ahead where I stopped. We'll be
Yeah.
using SolidWorks for this particular course. We'll be using SolidWorks for this particular course because it's the most used software by industrial designers. I know most of us are not familiar with it. We are familiar with Inventor, Autodesk Inventor. We are familiar with AutoCAD, but SolidWorks is the choice software for engineering designers and industrial designers. Basically, it's used mostly in Northern America, Canada, US. Everybody uses SolidWorks. So I would be switching over now to my back camera to show you guys what the interface looks like. So this is the interface of SolidWorks, and I will be showing you guys how you could install it. I'll be sending the link to the group after this meeting. Then I will show you guys how you can install it. Let me just try and create a new part now. So if you are familiar with Autodesk Inventor, you are familiar with AutoCAD, if you have any previous experience, you can definitely pick this up immediately. If you have no previous experience in engineering design as well, you can also pick this up easily. I'll be sending some materials and also tags that, okay, I've sent the first document that contains the tags. The first document is basically giving you guys a feel of what engineering design is. It's giving you a feel of what engineering design is, and the tags there also helps you guys to at least consciously do something related to engineering designing. Engineering designing is purposeful in the sense that you don't just design. Engineers are not visual artists or we are visual artists. We don't just pick up something and just say, okay, I want to make something and you just start making it like that. There are steps that you have to follow. We use a lot of geometry. There are dimensions that you have to follow. This has to be in your design for a particular reason. The kind of materials you use, the kind of geometry you use, even the shapes that you use in your design, everything must have a purpose. Engineering design is design under constraint, which means that we try to be we try to be purposeful. I don't use the same word, but we try to be purposeful when we are designing. For example, we have eco design, which means we design something that is environmental friendly. So is design under constraint. When you are designing under constraint, you have some certain things at the back of your mind that I'm trying to get the most power for the less for less weight. I'm trying to get the most energy I can get out of this particular space. Engineering design is systematic and iterative. It's a process that is always repeated. You always try and improve what you have. That's why we have new models of cars coming out every other year. That's why we have new that's why we have new models of cars coming out every other year. Send the link to the YouTube screen. Okay. Sorry. I'm sorry for the pause. Okay. That's why we have new models of cars coming out every other year, because engineering design is something that is iterative. Iterative is that once you get this answer, you try and see if you can get a better answer. So if I design, okay, let's say engineering design. Sorry, I'm using mechanical examples. I'm in mechanical engineering training. I make a car this year, and the top speed I can get from that car is 200. The top horsepower I can get from that car is 400 horsepower. The next one that comes out might look exactly the same, but I might have found a way to increase the horsepower from 400 horsepower to 500 horsepower, because design never ends, innovation never ends. You are never finished with a particular work. You just leave it at a particular point. That's what most designers will tell you, irrespective of their field. You are never actually done with something. You just build it up to the best that can build it up to as at that moment, and then you let it out. Next, engineering design is a social, collaborative enterprise. This is a process done in small teams that include people with different knowledge and experience. Designers are continuously communicating with clients, team members, and others. I can't emphasize that enough. As a designer, especially engineering design, you can't work alone. You are not a one-man army. That is why even the first task is for everybody. But then we will be doing some team projects throughout this course of this mentorship program. We'll be doing some team projects. Engineering design is collaborative. It's collaborative. There's some things that you're working on. You can't work on them alone. You need to break it up to different parts and have your team members do it with you. It's something that you need to rub your heads together, rub your minds together, and get around it. So basically, that's what engineering design is all about. I'll use the process again. You identify the problem, you define it, you gather information. The process of gathering information is you gather things such as, okay, why, how can I get this to do that? What material can I use for this? What material can I use for that? Okay, the problem is that this chair is not comfortable enough. My back starts to ache me after I sit down on this chair for about 2 hours. Then you gather information such as, why is my back even paining me when I sit down on this chair for about 2 hours? Is it the materials used? Is it the way the chair was designed? Is it the angle? Is it the angle of the chair? This is the right angle. Is there any way I can do it better that I won't get tired? Is it the height of the base of the chair? How far is it away from the ground? Does that contribute? That's you gathering information. Then the next step is to identify possible solutions. Okay, what if I lift up the chair a bit? What if I elevate the height from the ground? What if I change the angle of inclination of the chair from the regular 90 degrees like this to maybe 75 degrees, 60 degrees? So you identify possible solutions. The next thing after that is to generate or create a prototype, which is okay. You look at the multiple solutions and you analyze and say, okay, this one seems the best. Let me first change the angle of the chair this way. Then I see the effects. You create a prototype. After you create a prototype, you evaluate it or test it that, okay,
Does it actually make a difference? Back in the days, you need to create a prototype for almost every design. But these days, even though we would not be getting to that extent in this particular period of time, time would not allow us. These days, you could just test it on your system. You run FEA simulation, which is a finite element analysis simulation, and you can see, okay, it's it's better when it's slanted this way. It's better when it's slanted to this angle. It's better when I use steel to make my chair instead of plastic, or it's better when I use this instead of that. So once you evaluate and test, you go back to your prototype, then you refine it. When you refine it, that means you do the adjustments. When you do the adjustments, then you communicate it to others outside your circle. They come, they use the products, and then they can possibly identify another problem and show you the problem. Okay, I'm still having this issue with it. I'm still having that issue with it. That is the engineering design process, and you keep on going again till you can attain or get to a point that yes, it's good enough for anybody, every other person to use. So lastly, it's for me to show you how to install SolidWorks. One of the reasons why this meeting was delayed was because of my system was giving me issues with internet connectivity, so I had to switch to my phone. So that means that I can't still show you exactly how to install it. But what I would do instead is to write it down and make it as explanatory as possible, and I would send that to the group. So lastly, on the slide we have tax. Sorry if I'm not saying that right. The first tax after installing a rise stoner. Okay, a rise stoner basically is the machine that separates. It's self-explanatory. Rise stoner. It separates the stones from the rice paddies. It's used in agriculture. So some of us have eaten rice or even being self as I eating the rice, then the rice there's a little stone or something that almost shatters your teeth. So what a rice stoner does is that it gets rid of the stones in the rice. I'm not going to explain how it works, but basically, after installing a rice stoner, you bought one, you installed it, you notice that the vibration is too much, and instead of sieving out the stones from the rice paddies, it causes the stones to mix with the rice paddies. What design change can be made to devise the stoner to make it function optimally? So we've already identified the problem in the tax 1, tax 2, tax 3 actually. We've identified the problem. It's now up to you to come up with a possible solution and why that solution would make sense. So what I didn't put in the document that I'll be saying now is that you are to do this tax. I'll drop the deadline on the group chat. Do tax 1, do tax 2, do tax 3. You're just jotting it down. You're not designing something. You're just writing down the process that okay, this is what I can do to the rice the stoner to make it function optimally, and this is why I would suggest we make this design change. I would give an example. The vibration is too much. So what can you add to the machine or attach the machine to make the vibration less? That's that simple as that. Number two, despite having a good ventilation system, your power bike is still overheating. What design change can you bring to your power bike engine? What design what design change can you bring to the power bike engine to make it lose heat faster? So basically, you all know how let's say an Okada is or a power bike. The engines are like outside. You can see the engines, but then despite the engine being outside and air hitting it immediately, like it's constantly surrounded by air, so it's basically naked to the environment. The engine is still overheating. The engine is not losing heat fast enough. It's not as if there's a ventilation system coming in, there's air coming in, there is water coming in from the radiator, but then the engine is not still losing heat fast enough. So, what design change can you possibly bring to the engine to make it lose heat fast enough? I'll just give this away to those in the meeting. You could just simply attach fins to it. Fins, fins. you can Google engine fins. So I'm basically giving that out. So in the assignment, just put it there, engine fins, and then why you would attach engine fins or you would weld engine fins to that engine to make you lose heat faster. This third one, there's actually a price attached to it. There's a toddler in your house that is restless and always try to put his hands into the standing fan blades right on. So you have the fan spinning. You have the fan spinning. And then there's this kid in your house that just wants to put his hands into everything. And it's actually possible that he puts his hand between the frame and also the blade such that it injures his hands. And now you're concerned that what if I'm not watching? What if I'm in the room, I'm in the parlor, this kid goes into the room and stretches his hands into the fan to play with it and then it injures him. What radical change? I said radical intentionally. What radical design change can you do to the fan to completely eliminate the risk associated with the fan's blade? That means basically what I'm saying is that how can you get rid of the fan's blade without affecting ventilation coming out from the fan? You're not throwing away the fan's blade, but then you are also losing the fan's blade. So this third one, it actually has a price which is 1,000 naira airtime for the first person that can bring an answer. No answer is wrong, but the first person that brings the best answer or the most correct answer. So please, I want you guys to do each
What
and every
what
single
am
one
I
of these
currently?
tasks and submit ASAP. Just in the document format, just name it Unit 1 or Tax 1. As I stated in the document, it's the first tax, and put your name beside it. I would send a Google link. I'll send a link in which we would use to submit this first tax. So I look forward to you guys doing it and submitting it on time. Thank you. Please, if you have any question, kindly drop them in the chat box. If I don't get any question in the next 2 minutes, I would end the chat. I would end the live stream. Please feel free to ask questions. They will be attended to. I wish I could see your faces, but this is a Zoom call, so I can't see your faces so that we could have interacted better. I'm waiting for questions, please. I'm waiting for questions, please. Switch to my back camera. This is a bobcat that I designed recently. Well, not so recently, about a month ago on SolidWorks. And basically, it's something you use in a construction site. It has a lot of uses, but as you can see, it has a digger, so you could also use it for that. And because you could also use it to tow materials, move materials from one point to the other. So this is it on SolidWorks. This is it on SolidWorks. Okay, I'm not getting any question. So thank you for attending today's class.
Thank
We'll
you,
not be
Rama, for
having
having us.
live streams every other day, but because today was our first meeting, I said we have a live stream. So thank you very much for attending today's class. Any other questions that you might possibly have, please ask them on the Slack channel. Thank you.
Thank you, Rama, for taking us this session. See you guys in the next one. Bye.